What's up? Hi, everyone. So this is Module 1, Lesson 5, the distributive property. Woo! We just did, or you should have just walked through order of operations. Distributive property is the next step. It also has to do with the idea of grouping or parentheses. So very quick introduction before we jump into our assignment, okay? So we have seen it said that if you have something like this, 3 plus 6, parentheses, times 2, that order of operations tells us, I'm going to write it twice. Order of operations tells us do what's inside the parentheses first, regardless of what kind of operator it is. So we have two operations here. We're multiplying the 2 by what's inside the parentheses, and then we're adding the 3 and the 6. Usually we would multiply first, but when the problem is telling us, hey, do what's inside the group first, we're going to do what's inside the group first. So here I'm going to do it one way. 3 plus 6 is 9. That leaves me with 2 times 9. 2 times 9 is 18. That's using order of operation. The distributive property gives us a workaround. It gives us another way of doing it. And what it says is, hey, if you have something outside of the group that you're multiplying by the sum of the group, 2 plus 3, 3 and 6, if you multiply what's outside 2 by both things inside, we call them terms, the 3 and the 6, and keep the inside operator, you're going to arrive at the same answer. Really tricky to hear what that means when I explain it with words, so I'm going to show you what I mean. If you multiply the 2 and the 3, whoops, I'm going to go back to blue. If you multiply the 2 and the 3, I'm going to keep my operator. And then I'm going to multiply the 2 and the 6. I should arrive at the same answer I arrived at when I followed the order of operations. So let's see if I do. 2 times 3 is 6. I'm doing my multiplication first because now I am going to follow order of operations. And 2 times 6 is 12. 6 and 12 is 18. Lo and behold, it's the same thing. Couple of tricks that I want to offer you now. If this is negative, if I have a negative sign out here, that negative is going to go with the 2. This is going to be negative 2 times 3, negative 2 times positive 6, negative, negative, negative. Okay. Why does it matter? Doesn't matter. I don't really know. But let's say we had something like this. 2 plus x plus 4, where x is an unknown. I don't know what x is. So how do I add it to 4? Well, I can't because I have no idea what it is, right? It's like saying, hey, I have an apple plus $4. I only have one apple. If there's not a 1 next to the variable, we assume that there's one apple, right? So I only have one apple and I don't know how much it costs, plus $4. That's it. I can't combine, I can't add what's inside the parentheses because I don't know what that is. But if I'm multiplying the whole sum, x plus 4, by 2, I can manipulate this a little bit using the distributive property. I can take this 2 and I can multiply it by the x. And I can take this 2 and I can multiply it by the 4 per the distributive property. What do I end up with? I end up with 2 apples, 2 times x. I can bring them together when I'm multiplying, but I can't when I'm adding, because it's like saying, hey, I bought 2 of these things, right? Well, so part of what I bought 2 of. I bought the 2 apples. Plus 2 times 4 So I'm just going to skip a step here and just write 8. Okay, so I've changed 2 times the sum of x plus 4 to 2 times x plus 8. Did it help? Did it get me closer? Well, I don't know. I don't have any context for it, but there will be situations where this is much more pliable. This is a much more useful way of looking at this. There's things that I can do with the 2x plus 8 that I can't do with the 2 times the quantity of x plus 4. Okay, that was a very brief introduction to distribution. Let's look at the assignment. It's going to give us a little bit more to go on that might be exciting for you or not. I don't know. Probably not, but maybe. Let's see if we can make it exciting. Okay, unit 1, lesson 5, the distributive property, a whole lot of stuff about state standards that we don't care about. Learning target, in this lesson, you will use distributive property to simplify expressions. The word simplify is subjective. For some, it's simpler. For some others, it's more complicated. Some vocabulary: distribute, which is formally defined as give shares of something or to deal out. Like I was dealing out that number outside the parentheses. Okay. Richie lives in a neighborhood with a rectangular field. Looks like they're playing field hockey. Each part below shows a way to divide the field for different kinds of sports. Let's calculate the area. Okay, so they're going to use area as a big point of reference in this thing. Area, I'm going to have to stop and talk about area because if we don't know it, how are we supposed to learn this stuff, right? Okay, if I have a field, or let's not even talk about it in terms of a field, my dog's trying to get me. No, bad dog. If I have a field, and it is 2 units long, or 2 units wide, I should say. And let's say 4 units across, right? So each of these tiles is 1 unit wide by 1 unit across. And I have 2 units here and I have 4 units up here. And each of these is 1 by 1. We call that 1 square unit. All right, so this is 1 square unit. Boom, boom, boom. This is 1 square unit, so on and so forth. How many square units do I have total? 1, 2, 3, 4, 5, 6, 7, 8. 8 square units. Okay. And that is a unit of area. So if I were to say that apartment is 600 square feet, I'm talking about square feet, and the unit that I'm using is feet. So it's 1 foot across and 1 foot down. And we think of it in terms of tiles. That's what area is. That's our unit of measure for area. And how do we arrive at it? Well, how do we arrive at this if we weren't counting them? We would take the 2, that's our width, and we would multiply it by the length, that's our 4, and voila, we end up with 8 square units. I think I might have had too much coffee. Okay, we are going to clear this and stop share and go back to our handy dandy worksheet and see why that's relevant to the distributive property, which it is. Okay, so here we have a field that's 50 yards up and down wide and 120 yards across. So if I were to have done the same little drawing as I did with the 2x4, I would end up with 6,000 square yards, the 6,000 of those little tiles. All right, but now they broke it up differently because they want to play one game in one half of the field and another game in the other. They didn't break it up quite evenly. they drew a line at the 30 and the 20, and they drew it across. Okay, so they're making a point here. They're saying, look, the area of this field is not going to change. The area of the field is still the area of the field. I've just broken it up, right? So what was 50, they're now using parentheses to say 30 plus 20. 30 plus 20 is 50 by 120. 50 times 120 still equals 60,000. It never equals 60,000. That's wrong. 6,000, forgive me. Okay, let's scroll down a little bit. They're going to do some more funky stuff here. Now they've broken it up even further so they can play 4 sports on the same field. And they've broken this into 30 by 20 and 80 by 40, the 120 yards here. Notice it doesn't change because they're doing parentheses first, right? They're adding and then they're multiplying. It's following order of operations if you use parentheses first, right? Which they are. Cool. Let's scroll down a little bit more. To solve problems in mathematics, it is often useful to rewrite expressions in simpler form. The distributive property, illustrated by the area model below, is another property of real numbers that helps you to simplify expressions, numerical and algebraic. Okay, so in this case, look, they're saying this is x plus 5 or x plus 5 here. So this is a length that we don't know plus a length that we do know, 5. So to calculate the area, they're saying 8 times x plus 5, just like the 2 by 4 that we did earlier. And then they're showing how distribution works. You can think of this as 8x plus 8 times 5. The 8x, this part, is the area of this square here, the light green. Excuse me. The 8 times 5, which is 40 square units, is the area of this orange part here. And if you add them up, you'll get the total area. But we don't know what this x length is. So this is the simplest form that we could write this expression in. Or I guess it's, yeah, it's an expression. Okay, so here's some examples. Here's an algebra. Whenever you see 2 letters that are next to each other like that, so A times B plus C, AB plus AC, when they're next to each other, but there's no operator in between them, like there's that addition, but there's no operator between the A and the B or the A and the C, we assume it's multiply. We assume it's multiply. Similarly, when there's a parentheses and a number next to it, we assume multiplication is the operator in between them. So this reads A times B plus A times C. If I were to use the language AB plus AC, you would still assume that multiplication was the operator there. The big idea. Okay, areas equal length times width, we discussed that. If you had a rectangle of 10 feet by 5 feet, the area would be 10 feet by 5 feet, 50 square yards. We discussed that. The problems below are a little more complicated, so they'll work one out as an example. Write 2 different expressions to find the area of the rectangle below. Describe which one uses fewer steps. So here's 12. Give me my pen. Here's 12 times 3. That represents this area here. Because the length is 12 and the width is 3. And they're adding to it 12 times 7. This represents this area here. 12 times 7, right? So all those little boxes, like we broke up that candy bar a second ago, there would be 12 times 7 is 84 of them in here and 36 of them in here. 12 times 7 and 12 times 3 respectively. Okay, so that was the first way of doing it. The second way of doing it was to add the 3 and the 7 first, so that you had this whole length, and then you multiply it by 12. You're going to get the same answer. It's still going to be this entire area. But notice what we have here is the distribution property, distributive property modeled. 12 times 3, that's u. 12 times 7, that's u. Okay. Which expression takes fewer steps? Why didn't they do that? This was meant to be an example. Well, this is multiply, multiply, add. This is multiply, multiply, add. I think that number A takes the fewer steps, but I'm not really too worried about that because you would use them for different reasons, not necessarily number of steps wouldn't necessarily come into it. Okay, so write two different expressions to find the area of each triangle. I think I can do that. So here I have on the first one here, I have 12 times, I'm going to use the dot to represent multiplication. This is 12 times 3. This is going to give me this area here. And then I'm going to add 12 times 7. That's going to give me the next chunk. Or I can do it all in one go and say 12 times 3 plus 7, and I can add that with first. Okay. Okay. Number 2, I could go like this. I can say, what would happen if I added 4 and the 8? I would get the whole length, the whole. And then I'm going to multiply that by the whole width, which is 3 plus 7. And that's going to give me the whole length and the whole width, and I multiply them together and I get the whole area. Okay. Or there's a whole bunch of ways I could do this, but what happened if I just took the 4 and I multiply, let me erase this a little bit. Oops. Getting my pen right. If I just took the 4 and if I multiplied it just by the 3 and 7, I would get all of that, right? And then I could add it to, whoops, that's not an addition sign. I can add it to, I'm going to go the line down so I don't run out of space. 8 also times the 3 plus the 7. Which would give me this area here. And if I add them two together like I am, I'll get the whole area, right? Okay, 3 is very similar to that. So I'm not going to do it. You can do it on your own. 5, if I take the, 4, if I take the 5, I can multiply it by 17 plus 4, right? Close parentheses. I'm multiplying it by the sum of those two lengths to get my answer, 17 plus 4. That'll give me the whole area. Or I can go, what's the other option here? I can go 5 times 17. That'll give me the box on the left, plus 5 times 4. That'll give me the box on the right. And if I add the two of them together, I get the whole orange box. Cool. Cool. Okay, we're going to clear that. You can always pause it and come back to it. Write an expression to represent the area of the rectangle. Well, I know that area of rectangle is length times width. We've been discussing that. The length is 8. The width is x. I know that when I put a letter next to a number like that, multiplication is inferred. That means we assume multiplication. So that's good. I'm done. It says write an expression, so I don't have to have an equal sign. Okay. Here's something you need to know about distributing by a negative. See the example below. We discussed this briefly. So whenever there's not a number to the left of the parentheses, like here, we assume there to be a 1, because 1 times anything is itself, right? So sometimes I have an easier time if I think about this instead of just a random negative. I think about it in terms of a -1. Okay. So now I'm distributing my -1 in there. Oh, look, they did that. Multiplication property of -1. -1 times positive 2y is -2y, because a negative times a positive is a negative. And -1 times a -3x is a positive 3x. And I do want to point out that they made a step here. They used our pop rule, right? They went positive. There's my positive sign. Negative. There's my negative sign. So instead of thinking of that as a subtraction problem, they thought of it as a add the opposite of problem, which is always a safe bet when you're dealing with subtraction in algebra. And they made it into a positive, and then they made that a -3 instead of a positive 3. Well, and there's my answer. See. Okay, that is a great problem. Let's clean this up a little bit so we can see what's going on. When you are using the distributive property, you are multiplying the number or variable on the outside to numbers or variables that are inside the parentheses. If you have an expression like -3y minus 4, you're actually multiplying -1. We discussed that. Okay, that's just another example. Use the distributive property to simplify the following expressions. I do kind of want you to be careful, or I would prefer that the writer of this was a little bit more careful with the word simplifying, because there are times when this is simplified. Not always. In fact, most of the time they're correct, but simplify is sort of a subjective idea. Okay, so we've learned that this means to distribute. I'm going to allow this 2 to multiply by both of these terms. So this is 2 times 3 minus, because that's the relative operator, 2 times 5x. Okay, so I can multiply the 2 and the 5 and the x together, even though I don't know what x is. I can't combine like terms when I'm adding and subtracting. It's an important distinction, okay? So 2 times 3 is 6. I have a -2 and a +5, that's 10x. And then I'm done. That doesn't become -4x, okay? You cannot combine the 6 and the -10x. They're different terms. You cannot combine unlike terms through addition and subtraction, okay? Okay, all right, next up, y times quantity, y minus 30. Notice I used the word quantity. That infers parentheses. So if I say quantity, I mean, hey, there's a parentheses there. So what comes next is grouped. That's the way I'm using language. I'm going to do y times y, and we'll talk about what that is in a second. And then I'm going to go -30 times y. Okay, so y times y is going to leave me at 2y's. I don't know what y is, so I can't get a straight numeric answer from this, but I know that I have 30 of them because it's telling me 30, so it's minus 30y. I'm gonna rewrite the y times y on this next pass here. And we've talked about this earlier. Whenever a number is being multiplied by itself, or a number that we don't know, a letter, an unknown, we can use what's called exponents. That's the superscript up and to the right in a slightly smaller font size. Boom. I have 2 of them, minus 30y. If I had 3 y's, y, don't ask why. I can rewrite that as y cubed, or to the 3rd power. Sometimes we use the word cubed to describe that, like a Rubik's cube. When I use the number 2, y to the 2nd power, I oftentimes will hear people say squared. Why? Well, if you think about area, if I have y, if I say, hey, what's the area of this? It's y squared. It's y times y. Cubed, if it were a 3-dimensional object like a Rubik's cube, length, width, depth, we would go y times y, or y cubed, y making the shape of a cube. Okay, one more to do. Here's our example of our distributing -1. So I'm going to say -1 times 2 minus, I'm doing this one a little bit differently. I'm not using the bop rule. -1 times 2y. If you notice, that negative went out there, okay? You can always use the bop rule. I think it probably makes more sense. -1 times 2 is -2. I have a whole bunch of crazy negatives here. I'll rewrite it this way. Here's my subtraction. -1 times 2y is -2y. I would accept that as an answer, but if you really want to be slick about it, you can say -2. If I'm going to think of subtraction as adding the opposite number, I'm going to change this to an addition sign, and I'm going to add the opposite of the number. If the number is -2y, the opposite of the number is +2y. I don't need to write a positive sign because we assume positive. And here's our answer. Okay, are we done? Are we done? Are we done? Oh my gosh, we're done. All right, sweet. So we are done with unit 1, lesson 5, or I guess we're calling them modules. So let's look at the quiz. You know the drill. If you've been watching these tapes, you're going to pause it now, do the rest of the assignments, do the quiz, and you can come back to the video once everything is done, because I don't want to deprive you of the opportunity to figuring out this stuff on your own, okay? That's really where the learning happens. So, okay, so make sure to do the quiz and the rest of the assignments before you watch the rest of this video. So go away, then come back. Okay, simplify the expression -3 times 4x minus 1. All right, well, let's make this a little bigger. Come on. Okay. I'm going to distribute, because that's what we're doing right now, my -3. Those are meant to be parentheses. I'm going to multiply it by 4x. I am going to use the bop rule here because I think it's going to make for some cleaner mathematics. I'm going to go bop. So I'm going to add the opposite of. And I'm going to distribute my -3 into my -1. Negative 3 times 4 gives me negative 12x. I can do that even though the terms don't look alike because it's multiplication, okay? I can't do that if it's addition or subtraction. Plus negative 3 times a negative 1 is a positive 3. There we go. There's our answer for numero uno. Moving on. Okay, we have negative 1 times quantity, negative 2z minus 5y. Okay. I'm going to rewrite is equal to 2z minus 5y. The answer is false, but let's look at why. I'm going to rewrite the first part here, the first part of the equation. Oh, my dog's being naughty. No, bad dog. And I'm going to change, so it's subtraction, so I'm going to change it to adding the opposite of, okay? And then I'm going to distribute that negative 1 in. So negative 1 times negative 2z. It's his walk time. My dog. Plus negative 1 times negative 5y. Okay. Okay, I got distracted. So negative 1 times negative 2z. Negative times negative is a positive. 1 times 2 is 2. So, or 2z, I should say. 2z positive, which is indeed the first term of what the answer gives us. Plus negative 1 times negative 5y. That becomes a positive 5y because the negative times negative is positive. And there's our issue. This is negative. It's meant to be positive. The answer for question number 2 is false. Okay, ever onward. 2 more questions. We're going to clear this. Simplify the expression 5n squared minus 3n squared. Okay. The assignment didn't get too into this, but this is not distributive property, although it can be. This is more about combining like terms. Okay, so if I have 6 apples and then I add 3 apples, how many apples do I have? 9 apples, right? That's all combining like terms. That's fair, okay? If I have 6 apples plus 4 flats of apples, and by flat of apples, I just mean like you have like one of those trays that have 1 layer of apples in them. And I don't know how many apples are on flat, so I can't do any more math than that. Minus 4 apples because some worm ate 4 of them. Plus 2 more flats of apples. Plus $6, or I'm gonna use a different number, $8. Someone left me cash. I love that. So here's the deal. I can combine my apples. I can also combine my flats of apples. And if I had some more cash, I could add it to that 8, but I don't, right? I can't combine flats of apples with apples or with cash. I just can't. So this problem, while there looks like there's a lot going on, there isn't. There's two addition problems. I can add these guys, my 4 flats and my 2 flats, which is going to give me 6 flats of apples. I can take away what the damage the worms did from these other apples, and I can say I have 2 apples, and then I have $8, and I'm done. That's it. Boom. That's how it works. That's combining like terms. And that's how it works with addition and subtraction. If I were to multiply, if I were to say, hey, someone gave me 3 times this number of flats of apples, I can certainly make that an 18, but I can't add these apples to the flats of apples. Just can't. Okay. So going back to the problem, I think that might deserve almost a separate handling. If I have 5 flats of Nike shoes and I subtract 3 flats of Nike shoes, how many flats of Nike shoes do I have? 2. And that's it. That's all I can do to simplify this expression. Unless I knew what n was, but I don't. So, wah, wah. That's the right answer. Really odd. It's odd to me that they didn't talk more in depthly about combining like terms. We may have to go back and fix that at some point. Okay. So here we go. Same rules apply when you have different letters. So if I'm going grocery shopping, here it says which of these answers is the correct one when you simplify. I have 3 bananas here. I have 6 bananas here. I have 2 carrots here, or negative 2 carrots, I should say. And I have $8 here. And then over here, someone snagged 4 of them. Okay, so there's negative $4. What do I end up with? Well, how many bananas do I have? 3 plus 6 bananas. I have 9 bananas. How many carrots do I have? I have negative 2C carrots. There's no math to do here. Okay, so this one has 9 bananas and 2 carrots. So this is a possible answer. This one has 9 bananas and negative 2 carrots. This is a possible answer. This one has well, this one has 9 bananas, but they didn't combine them, and the question is asking us to simplify. So we can assume that this one's not the right answer. Okay, so what have I left off? I've dealt with my bananas, I dealt with my carrot, I dealt with my bananas here. I have $8, and then someone took away 4. That leaves me with plus 4. This one's minus 4. Goodbye. This has got to be the right answer. Addition is what we call associative. So we can, or communicative rather. So we can swap it around. We can change the order. As long as that negative is still to the left of the 2C, we're okay. If that were to become a plus sign, we'd be in trouble, but when it's not. So that is indeed our right answer. All right. We may have to do a special lesson in combining like terms because it feels like the course skipped it over, but we'll handle that when we get there. Okay. Thank you all very much, and I will see you again later. I should say also, there is a review. You don't have to do it. I encourage you to do it. You will not be turning it in. The test, however, you do have to turn in. Okay, cool. I think that's all I got. Bye.